In this video, we are going to learn about LCD interfacing. But first, have a look at LCD, liquid crystal display. An LCD is electronically modulated optical device shaped into a thin flat panel made up of any number of color or monochrome pixels filled with liquid crystals. An LCD display is specifically manufactured to be used with microcontrollers, which means that it cannot be activated by standard IC circuits. It is often used in battery-powered electronic devices because it requires very small amount of electric power. In recent years, LCDs is finding widespread use replacing LEDs. The main reason could be the declining prices of LCDs. That is, the LCDs have become cheap and are easy way to get text display for an embedded system. Common displays are set up as 16 to 20 characters by 1 to 4 lines. The most commonly used alphanumeric displays are 1 into 16, that is single line into 16 characters, or double line and 16 characters per line, or 4 lines and 20 characters per line. This is a simple example of 2 into 16 line LCD display. Now the pin description of LCD. While the pin VCC and VSS provide plus 5 volt and ground respectively, VEE is used for controlling LCD contrast, and this contrast can be adjusted by varying the voltage at this pin. This is done by connecting one end of the port to the VCC and another end to the ground, and connecting the central terminal, that is the wiper of the port, to the VEE pin. Now pin 4, RS, the resistor select. There are two very important resistors inside LCD. If RS is equal to 0, the instruction command code register is selected, and if RS is equal to 1, the data register is selected. Now pin 5, the read-write. The read-write input allows the users to write information to the LCD or read information from it. If read-write is equal to 1 when reading and read-write is equal to 0 when writing. Pin 6, the enable pin. The enable pin is used by the LCD to latch information presented to its data pins. When the data is supplied to the data pins, a high to low pulse must be applied to this pin in order for LCD to latch in the data present at the data pins. This pulse must be a minimum of 450 nanoseconds wide. Pin 7 to pin 14 are the data pins. The 8-bit data pins D0 to D7 are used to send information to the LCD or read the contents of the LCD's internal registers. To display letters and numbers, we send ASCII codes to these pins while making RS is equal to 1. Now this is the LCD commands table showing various LCD commands with their hex codes, and we'll learn about these commands in the next slide. This is a list of LCD instructions with their command codes, their description, and their execution times. One thing to be noted here is that execution times are typical. If transfers are timed by software and the busy flag is not used, we have to add 10% to the above time. Now the LCD datasheet. As we can see that one can put data at any location in the LCD, and the following shows the address locations and how they are accessed. We can see that the upper address ranges can go as high as 0100111 for 40 character wide LCD to 010011, that is 19 in decimal for the 20 character wide LCD. One thing to note is that the upper range 010011 is 39 in decimal, which corresponds to the locations 0 to 39 for LCDs of 40 into 20 size. This is a simple diagram showing the interfacing of LCD to 8051. We can see that the port 1 of 8051 is used to send the data, and the port 2 is used to send the control commands for like enable, read, write, and RS. This is again a simple diagram showing interfacing of LCD to 8051. We can see that pin 1 is connected to the ground, pin 2 is connected to the VCC, pin 3 VE is used to control the contrast. Pin D0 to D3 are left unconnected in 4-bit mode, and the read-write pin is connected to the ground during the write operation. Now we'll have a look at how to initialize the LCD. We have to send 38H to the 8-bit data line for initialization, and send 0F for making LCD on. Then send 06 for implementing cursor position, then send 01 for clearing the display and return the cursor. Now we'll have a look at the timing diagram of LCD read operation. We can see that whenever the enable pin goes from low to high and read write pin is high and register select pin is low, the LCD read operation is performed. Similarly, we'll have a look at the LCD write operations timing diagram. As we can see that whenever the enable pin goes from high to low and read write pin is low and register select pin is low, the LCD write operation is performed. This is a simple circuit diagram showing the interfacing of 16x2 LCD module with 8051. The capacitor C3, resistor R3 and push button switch S1 form the reset circuitry. Ceramic capacitors C1, C2 and the crystal X1 is related to the clock circuitry. The pin P3.3, P3.4 and P3.5 are connected to the enable, read write and register select of the microcontroller, and through this route the control signals are transferred to the LCD module. Now we'll have a look at the programming of the LCD. These are some basic rules. Data pin 8 DB7 of the LCD is busy flag and is read when read write is equal to 1 and register select is equal to 0. Whenever busy flag is 1, it means that LCD is not ready to accept data since it is busy with the internal operations. Therefore, before passing any data to the LCD, its command register should be read and busy flag should be checked. To send data on the LCD, data is first written to the data pins with read write equal to 0 and register select is equal to 1, and then a high to low pulse is given at the enable pin when data is sent. To send a command on the LCD, a particular command is first specified to the data pins with read write equal to 0 and register select equal to 0, and then a high to low pulse is given at the enable pin when the data is sent. Now this is a program showing how to send commands and data to the LCD with some time delay. To send any of the commands, we make pin RS equal to 0 and then send a high to low pulse to enable pin to enable the internal latch of the LCD, and for data we make RS is equal to 1. This is another piece of code showing how to send data or code to the LCD with checking busy flag. Notice that in above program that the busy flag is D7 of the command register. To read the command register, we make read write equal to 1 and register select is equal to 0, and a low to high pulse from the enable pin will provide us the command registers. After reading the command register, if bit D7 is high, LCD is busy and no information should be issued to it. Only when D7 is equal to 0, we can send data or commands to the LCD. In this method, no time delays are used since we are checking the busy flag before issuing commands or data to the LCD. Now this program shows how to use moves instruction to send data and commands to an LCD for an 8051 version of LCD programming. This is a very important piece of code and is added for the reader's convenience. Thank you.